So this function that you're seeing here, we are trying to run it on normalized data. So what I will do here is I will go here, and there is the university's dataset. You know how to read the XLSX file now in sheet 1 here, and within braces we're giving the path of the dataset. And we know for a fact that this dataset has a lot of irrelevant columns. 1 irrelevant column, 2 irrelevant rows. So we need to get rid of that, and there's a function we have already discussed in hierarchical clustering that we want rows 1 to 25, and when it comes to columns we want the first column in columns from 3rd to 8th, and we want to combine all those 1, 3, 4, 5, 6, 7, 8, and I'm assigning it to my data. Now this my data here has features which are of different units and different scales. Hence we need to normalize that. Using the scale function we are trying to normalize my data, and we're referring to all rows and 2 to 7 columns because we do not want to normalize this column. We cannot do that because we cannot calculate the average of universities. And let me normalize then. There we go. Now if you look at this k-means on the normalized data, how many clusters do we need to run? That's a question. And here we have normalized data. So I'll go back here and I'll explain you all on how to generate those that k value, how to get the appropriate k value. So here we are coming up with within sum of square formula, right? So when you try to analyze this, you'll come to know on what we are exactly trying to do here. So within sum of square is the distance between each data point to a specific data point, right? So let me run this. And if you look at this, I'll try to spend some time here rather than spending the time on the first one. Here, we are writing a loop from I in 2 to 8. So please pay attention here. I in 2 to 8. So if I equal to 2, so if I equal to 2, WSS of 2 would be equal to sum of k-means. You're running k-means clustering on the normalized data, and when you run k-means clustering on normalized data, you're telling that centers equal to 2, I equal to 2. So you're trying to run k-means clustering on normalized data, and we want how many clusters? 2 clusters. So you'll get 2 clusters. And each cluster will have bunch of data points, and you'll have a cluster centroid. And how do you calculate within sum of square distance of each data point to this centroid? So you will get 1 within sum of square for this cluster, and for this cluster also you'll get another within sum of square value. If you add these two, so how am I considering only within sum of square? Because I'm saying dollar within sum of square. Run the k-means clustering and pick up within sum of square and then add those sum of square. So you're adding this within sum of square with this within sum of square, and that is stored in WSS of 2. Now let me run this. If I run, it will make your life easier. So let me run that. Let me plot it. There we go. So that's your within sum of square for I equal to 2. And here is within sum of square on the y-axis. Turns out to be 60, yeah, roughly. Now, if we consider I equal to 3, it's WSS of 3. And you have k-means clustering that we are trying to run on the normalized data with centers equal to 3. So you'll have 3 clusters. And for each cluster, you'll have a within sum of squares. So you'll get a within sum of square for this, within sum of square for this, and within sum of square for the third one. And when you take sum of all these values, within sum of square 1 plus 2 plus 3, when you add these 3, you will get within sum of square for 3. So here for 3 clusters, the within sum of square value is so much. In that way, you keep changing I value until 8, and you get within sum of square for 8 values. And the underlying logic here is simple. We want clusters with less within sum of square, right? Less the better, of course. And here when you run it with 1 within sum of square, that means what are you trying to do? You're trying to consider or say that all these data points is one cluster. So you're ideally not creating any cluster. You're saying that all the universities are one cluster. How can that be? So you're ideally not doing any clustering. And for all the universities, if you try to calculate centroid and try to find out the distance of each data point from the centroid, you get within sum of square for one cluster, which doesn't make sense. So when you generated 2 clusters, the within sum of square value dropped drastically. So there is significant improvement because less the within sum of square, better it is. So if you generate 2 clusters, there will be significant improvement because until now you haven't generated any cluster. One cluster with all data points doesn't make sense. So for the first time when you generate clusters, here 2 clusters, you will see that there will be a drastic reduction in within sum of square. Now, if you notice, the within sum of square difference between 2 clusters to 3 clusters is so much. So much is the improvement because less the within sum of square, better it is. And if you change from 3 to 4, here also there is some improvement, right? Now if I move from 4 to 5, then the delta improvement that I can achieve is less. Hence I'm going to probably stop here and say let me generate 4 clusters. So the thumb rule is wherever you see a steep bend other than the first 1 and 2, other than that, wherever you see a steep bend, here I see slightly steep bend, and here also I see slightly steep bend. So I'm going to generate 1 cluster with 4. I'll run k-means clustering with 4 clusters. I'll run k-means clustering with 5 clusters. I'll compare these two and see for which cluster you're getting better results. When I say better results, high between sum of square and low within sum of square. This is called as a scree plot. And here we are trying to plot all those 1 to 8 values within sum of square. Type equal to B's, I want both circles and lines. X label is number of clusters, x-axis label. Y-axis label is within sum of square. Now you can also give an overall title to this, and the overall title would be k-means clustering of scree plot. Now, fine. Now we have decided that the number of clusters can be 4 or 5. So going back to our, university dataset. Don't look at anything else. Yeah, I'm trying to generate 5 clusters basically. So let me do that. And I'm running a k-means clustering on the normalized data with 5 clusters. How did you determine that there have to be 5? I've looked at the scree plot. So let me run that. And I've stored the output in fit. And this fit dollar cluster would have all the cluster values that, for example, structure of fit. If you do that, you get this. And fit dollar cluster would have all the numbers. So first university belongs to first cluster. Second university belongs to third cluster. Third university belongs to second clusters. Fourth university belongs to fourth cluster. So on, first cluster. So on and so forth. So this fit dollar cluster, I'm assigning it to my data, and I'm going to create the last column there and store it in final 2. There we go. So Brown belongs to first cluster, Caltech to third cluster, so on and so forth. If I want to move this from the last location to the first location, I just need to run this function. And now on this final 3, where you have this cluster name just beside the university name, I'm going to aggregate the data. Now look at what happens. I'm trying to aggregate all the rows of my data, right? This is your my data. I'm trying to aggregate all the rows from, and I want to consider second to 7th column. Needless to say, because the first column is university name. And I want to list it based on fit dollar cluster. Your fit dollar cluster would have the university name. So I want to list it by that. And the function that I want to use is mean. I want to aggregate using mean. And if I run this, you see here that, right, you have 5 clusters, and for, let me select a marker. If I ask you on, is this university, 5th one, is this tier 1, or is it tier 2, or is it tier 3? Which tier would you assign to the universities falling within cluster 5? So pay attention here. The SAT score is highest. So until unless you have very good score, universities would not accept. And out of the students who were accepted, 91% of the students were in the top 10 in their school days. And the acceptance ratio is very less. It's only 21%. Means if 100 people apply, only 21 people get admitted into this B school. And if you look at the student faculty ratio, it is very less, right? Apart from cluster 3, it is very less in comparison to the other clusters. And the expenses are fairly large. It's the second highest in these clusters. And the graduation rate is amazing. Majority of them are passing. So I get a sense that high score, top students in your school, not everyone is admitted. Student faculty ratio is pretty good. For every 10.5 students, you have 1 professor. Your expenses are slightly towards the higher end, and the graduation rate is amazing. I believe this is tier 1. So let us see, what is this? Cluster 5. I'm sensing now. Cluster 5. All right, yes, it makes sense. Harvard, MIT, Duke, Dartmouth, all these are part of cluster 5. Princeton, Stanford. Wow, so the clustering has done pretty decent job. Now, the success of the clustering is only and only determined if you analyze each and every cluster and determine or give it a label. Like tier 1 colleges is cluster 5. Probably from that perspective, I would say cluster 4 is tier 3 colleges. In that way, if you can give a name, tier 1 government or public colleges, tier 1 private colleges, which have slightly higher fee, maybe you can. For cluster 3, I would say it's tier 1 private colleges, because it has more or less the same standards as tier 1, but the expenses are slightly higher. This is how you need to do clustering. And here we have decided that we need to run I from 2 to 8, so 2 to 8 clusters. So using your domain knowledge, we need to determine because here I have only 25 universities. How many clusters do we expect maximum, right? So based on that, we take a call. It's all about your domain knowledge here, which gives you an indication on how many clusters you want to run for a scree plot. All right. And there is negligible difference between 7 and 8. Absolutely. So hence, we will not probably run with 7 clusters or 8 clusters.